Hey everybody, Mr. Rubo here. We're talking about absolute value equations today. Uh, just a reminder, absolute value equation, can look like this. Those are our absolute value bars. And remember, this just means it's the distance a number is from zero. And because we're talking distance, it makes it positive. So if you have absolute value of -5, it's 5. Absolute value of 5 is still 5. Okay. Um, so um, let's talk about solving these equations. So sometimes you might be able to just solve it in your head. So absolute value of x equals 5. Well, we just kind of gave that example. I know x could equal 5 because absolute value of 5 is 5, and x could also equal -5. Pretty simple, right? All right. Uh, Sometimes we can get equations like this, and hopefully at this point you're like, wait a second, that doesn't make sense, and that's good because it shouldn't. If you have the absolute value equal to just a negative number, so no variable, nothing else, this can't happen, right? This is not what the definition of absolute value is. Absolute value, when you do it, it has to give you something positive as its answer. Well, this is not positive, so this would be no solution. Okay? Um, those were the easy ones, though. So let's go to ones that will require us to do a little bit more work. Um, so I've got one here. 3 times the absolute value of x plus 3 minus 7 equals 11. All right, so here looks like a typical equation, except now we've got these absolute value symbols in. Um, so just like a typical equation, when you're trying to solve it, your whole point is trying to isolate this variable. Now the problem is the variable is trapped, if you will, in these absolute value symbols. So we still want to try to solve for it. Uh, so let's get rid of the stuff that's outside of it. So we always want to isolate, and we can't isolate this yet, just the x, but we can isolate the absolute value. So we're going to add 7 to both sides. We get 3 times the absolute value of x plus 3 equals 18. And then just like with an equation, you would divide by 3. So we get absolute value of x plus 3 equals 6. All right. So now, this is where the absolute value comes into play. So we know that if we think about what we just talked about up here, the absolute value of something could equal the positive of it, or it could equal the negative of it. Okay? So we're going to use that same logic right here. So here's the absolute value thing. It could equal the positive, or it could also equal the negative. So it could equal positive 6, or it could equal negative 6. Um, and now you just solve them separately, and you'll get two answers. So this one, subtract 3, and you get x equals 3. This one, you will also subtract 3, and you get x equals -9. Now, something that's really important with absolute value equations is you should always, always, always check your solution. So I'm going to check 3 first in blue here, and you'll see why, and really more so the next example, but it's still good to check it. So 3 times 3 plus 3 minus 7. And I'm trying to see, does that equal 11? So 3 plus 3 is 6. Still got technically the absolute values because I haven't dealt with that yet. This becomes just 6. 3 times 6 is 18. 18 minus 7 is 11. So this one works. Let's try the -9. So with -9, let's do it right over here on this edge. 3 times -9 plus 3 minus 7. That's going to be 3 times the absolute value of -6. And hey, absolute value of -6 is 6. 6 times 3 is 18. 18 minus 7 is 11. So both answers work. Awesome. All right, so that one wasn't too bad. And now let's look at an example where making sure you substitute in at the end there is super important. So here it's going to look a little bit more complicated than the last. So it's x plus 3, absolute value, plus 3x equals -1. All right, so now first thing, what I see a lot of students doing is they see this -1 and they think about that example I did earlier and be like, oh, well, this is no solution. But because there's this extra x that's outside of this, we could find a solution. It is still possible for it to be no solution, but we don't actually know that yet. So just like up above, we have to still isolate the absolute value because we can't break this up yet. So to isolate it, we got to move this 3x to the other side. Minus 3x minus 1. All right, so now we have isolated the absolute value. So now we go ahead and we do the positive version and the negative version. So it'll be x plus 3 equals, and then this side stays the same. And then we do x plus 3 equals, and then it's the opposite of this whole side. Okay, now because it's not just one term, you will have to distribute out the negative. Okay, and we'll do that once we get to that step. So let me just pull this up a little bit. Let's start solving. So it's just solving for x, so I'm going to add the 3x to this side, so I get 4x, subtract the 3, so I get -4, divide by 4, x equals -1. So that is a possible solution. This side, I'm going to distribute out that negative, so hey, it ends up all becomes positive. I'm going to subtract the x over, so I get 2x, subtract the 1, so I get 2, and when I divide, I get x equals 1. So now this is where you can get in trouble. If you just say, oh, these both are my answers, you'd actually end up being wrong. And I will show you why when we do our substitution. So for our substitution, we'll do this one on the left here. Let's substitute in -1 into the original left side of the equation. So -1 plus 3, that's in the absolute value, plus 3 times -1. All right, so that's annoying. So that's the original left side, and we want to see, does this equal -1? Well, -1 plus 3 is 2, absolute value. That's -3, that's 2, so 2 minus 3 is -1. This one works. So -1 is a good solution. Now let's do the same thing with 1. So that was the other solution we got. So let's substitute it in. So absolute value of 1 plus 3 plus 3 times 1. And we are, once again, checking, does it equal -1? Well, 1 plus 3 is 4. And then the absolute value is going to keep it 4. Plus 3 times 1 is 3. That's 7, which is not -1. So because this is not true, this solution does not work. Okay, this is what we would call an extraneous. Let me make sure I'm spelling this right. Extraneous solution. Okay, it's a solution that we got from our work, but it doesn't actually work because of the absolute value. The reason that we have extraneous solutions is when you look at the graphs, usually these extraneous solutions are points in the graph that if it wasn't for the fact that it was absolute value, it would normally hit it. You'll also see it with other functions as well, but extraneous solutions can happen, so that's the important, that's the most important reason why we check our solutions before we just say, oh, our answers are -1 and 1. Because in this case, you can see we actually only got the one solution of -1 to actually work. Okay? So thanks for watching, and have a good day.